Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it's time to continue further with the chapter of Mathematics class 12th, that is inverse trigonometric functions. And today is the turn of the lovely miscellaneous exercise. It is slightly difficult. Generally the miscellaneous exercise is found to be more demanding. For example, the questions are from all the topics covered in the chapter, and you have to revise the chapter complete and then solve the miscellaneous exercise. As well, go through the miscellaneous examples that are given in the textbook. That is something which you should do for solving this miscellaneous exercise properly. Right? Keeping that in mind, let's try and solve the questions over here one by one. The first question that says, find the value of the following. Cos inverse of cos 13 pi by 6. What's the value of this? Now, you may observe that cos inverse of cos x. Cos inverse of cos x will be equal to x if x lies in the range of cos inverse, that is 0 to pi. But this particular value does not lie in the range of cos inverse, that is 0 to pi. This value is greater than something. Greater than, actually you can say that this is 2 pi plus pi by 6, right? So obviously cos 13 pi by 6 can be written as this. Further can be simplified as cos 13 pi by 6 can be written as cos minus 2 pi as well, right or not? Right. You can add or subtract 2 pi without affecting the value of cosine, right? Without affecting the value of cosine. And this will further give me, this is cos inverse of cos 13 minus 12 is pi by 6. This is what you have. And what is cos inverse cos pi by 6? That is simply pi by 6, because pi by 6 lies in the interval 0, pi. And that's your answer for this question, which is very simple. Yes, this is very simple. Could we have thought in any other direction? We could have actually tried and found the value of cos 13 pi by 6 first and then dealt with it. But then instead of 13 pi by 6, if I am given, 13 pi by 6 is a nice angle. Instead of 13 pi by 6, if I am giving some random angle, then this method still works. But writing the value and all, then evaluating the value of cos inverse of that particular value will be possible only if this is a standard angle, right? In case of non-standard angles, this method still works, right? Keep that in mind and you'll be good to go. That's all for this question. Let's move on to the next one. This says tan inverse tan 7 pi by 6. We are supposed to find the value of this. Now, where does tan inverse tan lie? Tan inverse of something, the output should lie in the interval minus pi by 2 to pi by 2. That's fourth or first quadrant, right? But where does tan 7 pi by 6 lie? Tan 7 pi by 6, if you may be aware, tan 7 pi by 6 is pi plus pi by 6, which is in the third quadrant. What are we talking about? We are talking about this quadrant over here. This. Pi plus pi by 6. 7 pi by 6 is pi plus pi by 6, whereas tan inverse tan wants us to find an angle in this interval. Now, pi plus pi by 6 will be similar to this particular angle over here, that is pi by 6, right? So, what we can do is, from tan 7 pi by 6, from 7 pi by 6, we can reduce pi, since period of tan is simply pi, right? So this will be equal to tan inverse tan 7 pi by 6 minus pi. And here you will get tan inverse tan pi by 6. This is what you will get. You have subtracted pi from that angle and brought this angle in the first quadrant. You wanted the output of tan inverse to lie from here to here. That's from minus pi by 2 to pi by 2, right? That should be the output. So tan inverse tan pi by 6 will be equal to simply pi by 6, which is my answer for this question. That's pretty simple. Yes, with the help of this analysis, it's pretty simple to do this. Moving on to the next one. What does the question say? Let's take a look at this question next. Prove that 2 sine inverse 3 by 5 is equal to tan inverse 24 by 7. Okay, 2 sine inverse 3 by 5. This time we have 2 sine inverse 3 by 5, which is supposed to be equal to tan inverse 24 by 7. Now, do we remember any result related to 2 sine inverse? No. But we remember a result related to 2 tan inverse. What is that? 2 tan inverse x is equal to tan inverse 2x over 1 minus x square, and the condition that you wanted to remember over here is that mod x is less than 1 or x square is less than 1. That's what you wanted to remember, right? Mod x less than 1 or x square less than 1. This is what you should remember. Right. Once you have this thing clear in your mind, then after observing this question, the important thing that you realize is 2 times something is equal to tan inverse this. This sine inverse can be converted in terms of tan inverse, right? That is something which is important. So let's try to convert the sine inverse in terms of tan inverse first, and then we can apply that. Yes. So let's begin with this. Let sine inverse 3 by 5 is equal to theta. Sine inverse 3 by 5 will be equal to some angle, let's call that theta, which implies sine theta is equal to 3 by 5. Okay. At this stage, you can easily find the value of tan theta by using triangles. By drawing a triangle. If this angle is theta, this is 3, this is 5, this will be 4. Therefore, tan theta will be 3 by 4. But the NCERT people love some other methods which are analytical methods. Instead of this approach, they want you to follow a different kind of approach, write a few more steps. For the JEE, this is sufficient, 3 by 4. Tan theta will be 3 by 4. But then if you want to find tan theta using analytical approach, what we'll do is first find cos theta is equal to under root of 1 minus sine square theta. Since sine theta lies in the first quadrant, sine inverse 3 by 5 is equal to theta. Theta will lie in the fourth or first quadrant. The value of sine theta is positive, therefore theta lies in the first quadrant. Since theta lies in the first quadrant, we'll use plus sign for cos as well. Cos theta will also lie in the first quadrant, right? This is 1 minus 3 by 5. This will be actually 4 by 5, right? You can solve that. This will be 4 by 5. And which gives me tan theta will be equal to 3 by 4 sin theta upon cos theta. From here, you will get tan theta is equal to this. Implies theta will be equal to tan inverse 3 by 4. This is what you get. This is what you get, right? Let's get rid of this triangle. This is something which we used, but only in the rough, right? The exact method that you will be writing over here is this. Once you get theta is equal to this, therefore LHS, which is 2 sin inverse 3 by 5, became 2 theta, and that now converts to 2 tan inverse 3 by 4. Yes, this is what you get. Please note this. You started with 2 sin inverse 3 by 5. Sin inverse 3 by 5 was theta, but theta is also equal to tan inverse 3 by 4. So you replace that by 2 theta and further by 2 tan inverse 3 by 4. Once you have done this, then you can convert it into a single tan inverse. And how do we do that? Using that formula above. Tan inverse of 2 into 3 by 4 upon 1 minus 3 by 4 whole square. Okay. Where the square of 3 by 4 should be less than 1. That's important. This is 9 by 16, which is obviously less than 1. Yes, keep this in mind and you are good to go. What else? What will this convert into? Let's take a look at this. This is tan inverse. This is actually 3 by 2. In the denominator, you have 1 minus 9 by 16. This is 16 minus 9 by 16, right? The denominator will come in the numerator and the product. Okay. So this is tan inverse 8 times 3 is 24 upon 7. And is that what you wanted over here? Yes, we wanted exact same thing over here. This is my answer. This is hence proved. That's my RHS, and that's a complete proof of this question over here, right? Let's continue further and talk about this question. What does the question say? Prove that sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to tan inverse 77 upon 36. Now, what should we do in this one? So, can we add 2 sine inverses? No, we don't have any result related to addition of 2 sine inverses in the NCERT, right? Although people studying for the JEE examination would realize that sine inverse can be added using some ideas with that, right? Sine inverse x plus sine inverse y is equal to sine inverse x under root of 1 minus y square plus y under root of x minus 1 minus x square, where x square plus y square should be less than 1, right? That should be the case. And what about this one? So for this question, what we'll do is, we can convert this in terms of tan inverse and this in terms of tan inverse, and we know a result to add to tan inverse, that is tan inverse x plus tan inverse y. What is the result for that? Let us write the result properly. Tan inverse x plus tan inverse y is equal to tan inverse x plus y over 1 minus xy. The condition that should be followed is x greater than 0, y greater than 0, and xy should be less than 1. This is the condition that is important for us, right? X greater than 0, y greater than 0, and xy, the product should be less than 1. Okay, since we want to use that formula, let's try to convert this and this in terms of tan inverse first. Okay, let sine inverse 8 by 17 is equal to theta, and sine inverse 3 by 5 is equal to some other angle phi. And now we'll apply similar steps, because this is also sine inverse, this is also sine inverse. We are supposed to convert them in terms of tan inverse. This gives me sine theta is equal to 8 by 70. This gives me sine phi is equal to 3 by 5. Okay, let's draw a triangle. Yes, you can draw a triangle and get the value of tan theta very easily from here. Or you could use analytical method, that is, first find the value of cos theta. 1 minus 8 by 17 whole square and under root. Okay, what does this give us? Please observe, 17, 8 and another 1 which is 15 are Pythagorean triplets. How do we get that? This 17 square which is gone over here, 17 square is 289 minus 64, 289 minus 64 is 225. Numerator you will have a 225. Denominator you will have a 17 square. What is that? 15 upon 17. This gives me cos theta is 15 upon 17. What about this? This gives me cos phi is equal to under root of 1 minus 3 by 5 whole square, which is pretty simple. This is 4 by 5. And once we have found cos theta, sin theta, you can find tan theta. Tan theta is equal to this upon this, which is 8 upon 15, giving me theta is equal to tan inverse of 8 by 15. This is the value of theta, right? What about this one? Therefore, tan phi is 3 upon 4, that is sin phi upon cos phi. And this gives me phi is equal to tan inverse 3 by 4. Once you have found the values of theta and phi, again, yes, because you started with theta and phi, right? And you found that value again. So, therefore, the LHS is theta plus phi, which is actually equal to what? In the LHS, you have theta plus phi, which is equal to tan inverse 8 by 50 plus tan inverse 3 by 4. This is what you have, tan inverse 8 by 50 plus tan inverse 3 by 4. And if you observe, this is positive product. The product, as you can clearly see, is 24 upon 60, which is less than 1. The product is less than 1. So, using this identity over here, what do we get? This can be converted into tan inverse sum, that is x plus y over 1 minus xy. This is what you are supposed to do, right? Tan inverse x plus y over 1 minus xy. Let's take the LCM. Let's multiply with 15 into 4, 60. Let's multiply by 60 in the numerator and 60 in the denominator. What do you get? This is tan inverse. 60 upon 15 is 4. 8 times 4 is 32. Plus 60 upon 4 is 15. 15 times 3 is 45. Okay, 60 times 1 is 60 minus 60 in the denominator, and this is 8 times 3, which is 24. What does that give us further? That gives us tan inverse. This becomes 77 over 36. Is it? Yes. And what do we want? We wanted the exact same thing. Yes, we wanted the exact same thing. This is equal to the RHS, and that is the complete proof of this question. That's proof. Yes, complete. Simple. Yes. The important thing was to realize that we don't know the sum of these, but we know a result in terms of tan inverse, addition of 2 tan inverse, that is tan inverse x plus tan inverse y. We know that result and we want to apply that result. So let's convert this in terms of tan inverse, let's convert this in terms of tan inverse, and if you can guess that properly, you can approach the question in a very simple manner. You will convert in terms of tan inverse and then use this result very easily, right? So this question in itself is a combination of 3 simpler questions: interconversion, and then addition of this formula. 3 simple questions have been clubbed together to make this question over here, right? That is all for this question in this here. Let us talk about the next one. What does this question say? Cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 upon 35. Now how do we deal with this? Okay, do we no result related to cos inverse x plus cos inverse y? NCERT does not give any such result, but in case you are preparing for the JEE examination, you can use your result of cos inverse, that is when, what do you have? Cos inverse x plus cos inverse y, right? So cos inverse xy minus under root of 1 minus x square, under root of 1 minus y square, you can use that result. But right now, when we are talking about this question from the point of view of NCERT, what are we supposed to do in this case? We are supposed to deal it in a simpler manner, right? We know one result to add 2 IDFs, that is tan inverse x plus tan inverse y, and we'll use that. This is the result that I am talking about. This is equal to tan inverse x plus y over 1 minus xy, where x comma y are greater than 0 and xy, the product is less than 1. This is the result that I am talking about. This is the result that we are looking to apply. Oh, but there is no tan inverse on the right hand side. Why worry about that from the very beginning? We will convert this in terms of tan inverse, this in terms of tan inverse. You will add them together. You will get a result in terms of tan inverse. Yes. You will convert that again in terms of cos inverse and you will get that. Oh, is it so? Yes. Yes. Then let's do it. Yes, let's do it. Let's begin by writing let cos inverse 4 by 5 is equal to theta. Cos inverse 12 by 13 is equal to phi. This gives me that cos theta is equal to 4 by 5. By the way, from here you note that theta, since cos inverse 4 by 5, the output will be theta. The output should lie in the interval 0 comma pi. So this theta lies in the interval 0 comma pi. But since cos theta is equal to 4 by 5, the value of theta will lie in the first quadrant. Right? From first and second, we have chosen the first quadrant as you can see over here. Right? Since cos theta lies in the first quadrant, sin theta, obviously, first quadrant will be positive. Therefore, sin theta, which is under root of 1 minus cos square theta, will be equal to 3 by 5. Very easily. Right? How did you get that? Oh, 1 minus 4 by 5 whole square and Pythagoras theorem, you can easily get that, right? Okay. What about this one? Cos phi is equal to 12 by 13. Once again, phi over here, since it is output of cos inverse, it would have lied in the first or second quadrant. The value of cos phi being positive, phi lies in the first quadrant. Therefore, sin phi will be equal to under root of 1 minus 12 by 13 whole square. What does that give me? This is 5 by 13 simply. Oh, is it so simple? Yes, you can write that very easily. If you may remember the Pythagorean templates, this is 5 by 13. 5, 12 and 13, right? That's what you're looking at. And this gives me tan theta is equal to sin theta upon cos theta, which is 3 by 4, which gives me theta is equal to tan inverse 3 by 4. We wanted to find the value of this in terms of tan inverse. We have done that, yes. Similarly, let's find tan phi over here. Tan phi, mind you. Tan phi is equal to sin phi upon cos phi, which is 5 by 12. Okay, therefore, which gives me phi equals tan inverse 5 by 12. Okay. What next? Since phi is equal to this, therefore, in the LHS, you have theta plus phi, which is tan inverse of one angle, that is 3 by 4, plus tan inverse of 5 by 12. Realize this is less than 1, this is less than 1. The product will also be less than 1. Yes, the product will also be less than 1. Therefore, I can apply this result over here, which is given at the top. Apply that. This will give me tan inverse of 3 by 4 plus 5 by 12. 1 minus 3 by 4 times 5 by 12. This is what you'll get. Right, yes. What next? What's the LCM of 4 and 12? It's 12. Let's take the LCM in the numerator and simplify this further. This is tan inverse. What you get is, in the denominator you'll have a 12. Okay. And this will become 4 times 3, which is 3 times 3 is 9 and 9 plus 5 is 14. Okay. What about this denominator over here? This is 12 times 4, is it? No. 3 times 4 is 12. So we'll have these terms get cancelled. This is what you'll get. And in the denominator, therefore, you'll get a 16, 16 minus 5. 16 minus 5 is 11 in the denominator, and denominator 16 will go at the top over here. This is what you get over here. This is what you get. This is the value of tan inverse. Can we simplify this further? Yes. This is further equal to tan inverse of, what do you get? 12 and 16. 12 has a factor of 4. Yes, 16 also has a factor of 4. This becomes 3. This becomes 4, right? Okay. And what's 14 times 4? And what's 3 times 11? 56 upon 3 times 11 is 33. That's the question in front of us. Yes. And what next? Can we convert this in terms of cos inverse? Yes, we can convert this in terms of cos inverse. Once again, using the similar ideas that we have discussed over here. I think, okay, this is 33 and this is 56. The denominator should be greater than 56. Okay, there may be some kind of an issue in this 33, but this may be changed, right? Let us check what that value will be, and there's some correction required over here, right? There's some correction required, yes. But let's first get the value, what we'll be getting. Tan inverse 56 upon 33, can I convert this in terms of cos inverse? Yes. Is equal to, let's call this equal to, that's theta, phi, let's call this alpha for a minute. Okay. If this is equal to alpha, then tan alpha is equal to 56 upon 33, which gives me sec alpha can be easily found by the help of under root of 1 plus tan square alpha. What is that? Under root of 1 plus 56 square upon 33 square. This is what you have. 33 square and 56 square, right? Can I add them together? Yes. What I'll get is, let's see, where does that take me? This is under root of 33 and 56 are two very big numbers, two relatively big numbers as compared to when we talk about the normal Pythagorean triplets that we are aware of. If you are aware of these Pythagorean triplets, then it is very good. But if not, let's find that. In the numerator, you'll have a 33 square. Now, what does 33 square look like? 33 square will be 3 square, that is 9, and 3 times 3, 9, 9 times 2 is 18, 8, and 1 carry 3 times 3 is 9, 1089 plus. What you get over here is 56 square. 56 square will be equal to what? 56 square will be 6 square, 36 over here. 3 carry, 6, 5, 30, 60 times 60 plus 3 is 3. 6 carry, and 5, 5, 25 plus 6 is 3, 1. 3, 1, 3, 6. This is what you get. In the denominator, you have 33 square. That's what you have. Right? Let's add them together in the numerator. And what you get is, let's take a look at this. 9 plus 6 is 5. 3 and 8 is 11 plus 1, 12, 2, 1 carry, and 31, 41, 42. This becomes 42. 4225 upon 33 square. This is what I get. 4225, yes, this is a number which is square of some particular number. Yes, what is that number? If you may recall some results related to squares of numbers ending in 5, you would realize that this is square of some number ending in 5. And 42 is actually 6 times 7. This is 65 square. So this becomes 65 over 33. Okay. So sec alpha becomes this. Therefore, cos alpha becomes reciprocal of this, or alpha becomes equal to cos inverse of 33 upon 65. And yes, that was the correction that I was looking at. This is not 35, this is actually 65 over here. Okay, we had to prove this equal to this 33 upon 65. And have we done that? Yes, we have done exactly that. This comes out to be tan inverse 56 upon 33, which is actually equal to cos inverse 33 upon 65. This is my RHS. Hence proved. Okay, this is my RHS and hence proved. Is it a long? No. Conversion of this and this takes least application of your brain, and basically you can get this result. Using this result, you can get the answer very easily. Using this result of addition of tan inverse x plus tan inverse y, you can get a result very easily. Okay, this particular method, when you look at this method is applicable throughout all questions of this kind. When you add two in ITF and you have another ITF on the right hand side, you can always convert in terms of tan inverse and get your result. But in case you have, let us say, cos and cos on the LHS and another cos on the RHS, you can use one more idea. What is that one more idea? Let me discuss that as well. This is theta and this is phi. Okay, so you're actually looking at cos of theta plus phi. Imagine this as cos of theta plus phi. That's what you're looking at, right? And what does cos of theta plus phi equal to? Let's think that for a minute. Cos of theta plus phi will be equal to cos theta cos phi minus sin theta sin phi, which we have found over here, right? So you have found cos theta cos phi, you have found sin theta sin phi. You can use that to get cos of theta plus phi easily, right? And then take cos inverse throughout. What are we talking about? Let me write the steps in front of you. Let me write an alternative step. Will require these things, will require these steps still, but the alternative method would imply that we will not need to apply this one. Will not require to apply this one. Okay, so which one should we prefer? We should prefer this one, but then let me discuss the other one as well. Because you are sure to encounter those kind of methods as well, that method as well. What do we have? In the LHS you have theta plus phi, right? Let's talk about cos theta plus phi first, right? Let's talk about cos theta plus phi. This is equal to cos theta cos phi minus sin theta sin phi. What does this become? Cos theta is 4 by 5, cos phi is 12 by 13 minus sin theta is 3 by 5 and sin phi is 5 by 13. What does that give us? In the denominator you have a 65, which is the LCM, right? This 12, 4, 48 and this is 15. This gives me 33 over 65. Oh, that makes life very simple, yes. This gives me cos of theta plus phi is equal to this, or you can say that theta plus phi is equal to cos inverse of 33 upon 65. Now what is theta? Theta is cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 35, and that's the complete proof of this question. That's another way in which you can tackle the same question. This is method 2, wherein we require this, and other than that nothing much as such, right? This is a complete proof of this question, and those are all the aspects which we wanted to discuss in this question. Let's move on to the next one after this. Let's talk about this question. Cos inverse 12 by 13 plus cos inverse plus sin inverse 3 by 5 is equal to sin inverse 56 upon 65. Okay, what are we supposed to do in this one? So one of the approaches, as we discussed in the previous question, is to convert this in terms of tan inverse, this in terms of tan inverse, and then apply tan inverse x plus tan inverse y. Or alternatively, since this is sine inverse of something, we can find sine of theta plus phi, right? Let's do that. Let cos inverse 12 by 13 is equal to theta and sine inverse 3 by 5 is equal to phi. This gives me cos theta is equal to 12 by 13. This gives me cos theta is equal to 12 by 13, and this gives me sin phi is equal to 3 by 5. Okay. Can I find the values of sin theta and cos phi from here? Yes. Sin theta will be equal to under root of 1 minus cos square theta, which is 12 by 13 whole square. What is that? 5 by 13. Pretty simple. Yes. And therefore cos phi will be equal to 1 minus 3 by 5 whole square, which is equal to 4 by 5 over here. That's what you can note clearly. Please note these things too. These two things. Yes. Once we have done that, what are we looking at? This is theta, this is phi. We are looking at sine of theta plus phi. Therefore, sine of theta plus phi is equal to sine theta cos phi plus cos theta sin phi. Okay, what is this equal to? Sine theta is 5 by 13. Cos phi is here 4 by 5 plus cos theta is 12 by 13. Sin phi is 3 by 5. Okay. In the denominator you get 65, right? In the denominator you will get 65. What about the numerator? In the numerator you will get, this is 5 4 is 20 and 12 times 3 is 36. 36 plus 20 is 56. And therefore theta plus phi will be equal to sine inverse of 56 about 65, or you can say that theta as we began with was cos inverse 12 by 13 plus phi is sine inverse 3 by 5, which is equal to sine inverse of 56 over 65, and that's the complete proof of this question over here. That's the complete proof of this question over here. Pretty simple? Yes, pretty simple. Okay, what else? No, there's nothing else in this question. This is all in this question. We could have moved in the direction of applying tan inverse x plus tan inverse y as well. This is also possible. Let's talk about this question next. Tan inverse 63 upon 16 is equal to sin inverse 5 by 13 plus cos inverse 3 by 5. In this case, when we need the result in terms of tan inverse, let's use concepts of tan inverse. In the RHS we have two terms. And let's simplify those terms first. Let's see what those terms are in terms of tan inverse. Let sin inverse 5 by 13 is equal to theta, cos inverse 3 by 5 is equal to phi. This is this, right? This gives me sine of theta is equal to 5 by 13, which gives me cos theta is equal to 12 by 13, and tan theta will be equal to simply 5 by 12. Oh, we have been doing this for so long that cos theta and tan theta are not very difficult for us, right? We could also have drawn this triangle and observe the values as per this theta very easily. This is 5 by 13, sin theta is given. By Pythagorean theorem, this base will be equal to 12, right? Similarly here this gives me cos phi is equal to 3 by 5, which gives me sin phi will be equal to under root of 1 minus cos square phi, which is 4 by 5. And further tan phi, the value of tan phi can be easily found, that will be 4 by 3. Okay. Once you are through with this, in the RHS, you have sin inverse 5 by 13, that is theta plus phi. Right or not? Yes. Okay. And theta is further equal to tan inverse 5 by 12 plus tan inverse 4 by 3 over here. Right? This is what you have. This is x, this is y. What about the product of x, y? If you observe, this is 5 times 4 is 20, 12 times 3 is 36, 20 by 36 is less than 1. Therefore, I can apply the result tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. This is what I want to apply. You can take the LCM. 12 times 3 is 36. Let's multiply by 36 in the numerator and denominator. What do you get? Is tan inverse 15 plus 48 over 36 minus 20. This is what you get. And what is this equal to? This is equal to tan inverse of 63 over 16, which is my LHS. Hence proved. That's the complete proof of this question. You began with the RHS and you proved that it is equal to the LHS. That's all for this question. Let's talk about this question next. Oh, there are so many tan inverse in the LHS, right? So, what are we supposed to do? We are supposed to simplify them. There are 4 tan inverse, right? So, we can add these two using tan inverse x plus tan inverse y. We can add these two using tan inverse x plus tan inverse y, and let's see where does that take us. We will be using tan inverse x plus tan inverse y is equal to tan inverse. Here x, y, the product should be less than 1, x greater than 0, y greater than 0. This is important. Those are the conditions which are very useful, right? Once we know this much, then can I add the first two tan inverse? Yes, we can begin with the LHS. Tan inverse 1 by 5 plus tan inverse 1 by 7. Let me write the question first. And now I want to add these two. I want to add these two. We are supposed to add two terms, right? This will convert into a single tan inverse because the product of xy is obviously less than 1. This is less than 1. This is less than 1. The product will be less than 1. What is this equal to? This is 1 by 5 plus 1 by 7 over 1 minus 1 by 5 times 1 by 7 plus tan inverse of this 1 by 3 plus 1 by 8, 1 minus 1 by 3 times 1 by 8. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Okay. This further gives me tan inverse of 7 plus 5, which is 12, over 35 minus 1, which is 36. Sorry, 34. Don't make a mistake in that. This is, in the numerator you get 7 plus 5, which is 12. In the denominator you get 35. And this is 35 minus 1, which is 34, right? Plus tan inverse, the other term, what you get over here is, take the LCM. This 8 times 3 is 24. 8 plus 3 is 11 over 24 and 24 get cancelled. This is 24 minus 1, which is 23 over here. Okay. Once again, we have two tan inverses. That is tan inverse x plus tan inverse y, wherein this is less than 1, this is less than 1. Therefore, the product xy will be less than 1. I can apply that same result, right? Without worrying about anything. I can apply that same result. This gives me tan inverse of 12 by 34. Okay. Plus 11 by, and can I actually divide by 2 in the numerator denominator? Yes, I can do that. Let's do it. This is 6 by 17 plus 11 by 23 over 1 minus 6 by 17 times 11 by 23. This is what you have. This is what you have. Let's say this is what you have. Once you're done with this, next, this is equal to tan inverse of 6 times 23. Let's take the LCM. 6 times 23, 17 times 11. That's what we're looking at. 6 times 23 is 138. Yes. Plus 17 times 11 is 187. Over 17 times 23 is what we require over here. What's that equal to? If you observe, this is 20 minus 3, this is 20 plus 3, which is actually 20 square minus 3 square. 400 minus 9 is 391. Minus 6 times 11, which is 66. Okay, this is what you have, right? Can we check that product? The 7 times 3 is 21, 1 and 2 carry actually. 7 times 2 is 14, 15, 16, 17, 18, 19, 9. 1 carry, 2 times 1 is 2, plus 1, 3. 391 is okay. 391 minus 66. This is what you have over here. The terms in the numerator, can we please also check that? Yes. 6, 3, 18, 8. 1 carry, 6, 2, 12, plus 1, 13. Yes. 17 times 11 is 187. That's okay. Yes. 7 times 1 and 7 times 1 plus 1, 8. This is okay. Let's add them together. This is tan inverse of, what is this simplifying into? Let's see. 8 plus 7 is 15. 1, 2 and 3. 325 is what I'm getting over here. What about 391 minus this 66? This 91 minus 66, which is 2, and 11 minus 6 is 5 only. This 325 upon 325, which is tan inverse 1. Oh, tan inverse 1 is pi by 4. Okay, so this is my answer. No, this is the RHS. We started with the LHS and we wanted to reach this stage, which is the RHS, and have we reached that? Yes. That's the complete proof of this question over here. That's all. Let's try and solve this one next. Prove that tan inverse root x is equal to half of cos inverse 1 minus x over 1 plus x. How do we go about proving this? If you observe, there's a complicated expression on the left hand side because you have root x inside tan inverse. You have another very complicated expression on this side. Okay. So what are we supposed to do in this one? Let's take a look at this question. Let this tan inverse root x, can I assume this to be something and find x? Then I can substitute this and maybe simplify this. Yes. Let tan inverse root x is equal to theta. Mind you, let tan inverse root x is equal to theta. Now output of tan inverse would have lied in minus pi by 2 to pi by 2. Therefore theta would have lied in minus pi by 2 to pi by 2, except for the fact that you have been given some particular values of x. Since x belongs to 0, 1, therefore this will lie from 0 to pi by 4. Yes, where x belongs to 0, 1 implies theta belongs to tan inverse 0 to tan inverse 1, which is 0, pi by 4. This is what you have. Closed and closed. Right. Okay. This gives me root x is equal to tan theta. This gives me x equals tan square theta. Okay. You have found the value of x by now. Assuming that tan inverse x equal to theta, you have found x equals tan square theta, where theta lies from 0 to pi by 4. Now take a look at the RHS. Now in the RHS, what do you have? In the right hand side, because realize that this equal to theta implies this LHS has been simplified into theta, right? So if this also equals theta, then we are done. So let's try to simplify the RHS. RHS is half of cos inverse 1 minus tan square theta over 1 plus tan square theta. Ooh. Is that okay? Yes. X is tan square theta and 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. You remember that? Yes. 1 by 2 cos inverse of cos 2 theta. Is it? Yes. This is something that we remember. On the basis of this, what we can say is, therefore, RHS is further equal to 1 by 2. If you observe theta belongs to this interval, then 2 theta belongs to 0, pi by 2, which is the first quadrant. Yes. Okay. And cos inverse cos, the output should lie in the first or second quadrant. If it is lying in the first quadrant, it is okay. So this becomes half of 2 theta, since 2 theta belongs to 0 comma pi by 2. Please note this, 0 comma pi by 2 over here. Yes, yes. Okay, now RHS is half times 2 theta, which is equal to theta. And what is theta? Theta is tan inverse root x only. And yes, this is my LHS, hence approved. Simple, yes, pretty simple. Oh, we began with something different. We began with tan inverse root x equal to theta. Yes, we had to begin somewhere. And seeing this expression also, you would realize that this is 1 minus, you want to convert 1 minus 6 upon 1 plus 6 in terms of cos something, right? And cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. Remember that formula from your trigonometry class 11th, right? Okay, this is all for this question over here. Let's discuss this question next. What does the question say? Cot inverse under root of 1 plus sin x plus under root of 1 minus sin x over under root of 1 plus sin x minus under root of 1 minus sin x is equal to x by 2, where x belongs to 0 comma pi by 4. Now, how do we approach this question, right? This is 1 plus sin x. Do we actually think about one of the approaches? Maybe, so let's think about rationalization. You may go about doing rationalization, but then there's a simpler approach which you can follow if you remember one thing. Will rationalization not work? That will also work. But there's another approach that I can follow over here. And what's that? I know some results from trigonometry, and therefore I want to use those results. What is the result I'm talking about? You remember sin x plus cos x, and if I square this, what will I get? This will give me sin square x plus cos square x, which is 1, plus 2 sin x cos x. 2 sin x cos x is nothing but sin 2x, right? So this is sin 2x. Okay. So if I take the under root of both of these, what you get is under root of this. Okay, let me write that again. This is sin x plus, or let me write sin x by 2 plus cos x by 2 whole square is equal to what? This is sin square x by 2 plus cos square x by 2, which is 1, plus 2 sin x by 2 cos x by 2, which is sin x. And if I take the under root of both sides, what I'll get is under root of x square is mod x, which is sin x by 2 plus cos x by 2 modulus is equal to under root of 1 plus sin x over here. Had I had a minus over here, this will become minus over here. Okay, sin x by 2 minus cos x by 2 modulus will be equal to under root of 1 minus sin x modulus. Under root of 1 minus sin x. Now what about modulus of x? Since under root of x square is equal to modulus of x, this will be equal to either x or minus x, depending upon x this or x less than 0, depending upon the values of x, whether this x is positive or this x is negative. If this x is positive, this will be simply equal to x. If this x is negative, this will be simply equal to minus x. Those are some things that we already know. Since we know these things, can we apply these concepts on this question over here? What do you want to do? Let's take a look at this. I have something in the LHS. What's that? Cot inverse of under root of 1 plus sin x. I want to write under root of 1 plus sin x as modulus of this. Is that okay? Yes. This will be equal to simply under root of sin x by 2 plus cos x by 2 whole square. Okay. Plus under root of this is sin x by 2 minus cos x by 2 whole square. In the denominator, you have these terms but separated by a minus sign in between. Same terms. This is what you have. And this further will be equal to what? This will be under root of x square, which is modulus of x. So this gives me cot inverse of modulus of plus similar thing over here, modulus of sin x by 2 minus cos x by 2. In the denominator, you have same terms but separated by a minus sign. Is that okay? Yes. Once you're okay with this much, then This sin x by 2 plus cos x by 2 is this value positive. This sin x by 2 minus cos x by 2 is this value negative. Let's analyze that. So for that we require the values of x. Since x belongs to 0 comma pi by 4, let's analyze that. X belongs to 0 comma pi by 4 implies x by 2 belongs to 0 comma pi by 8. Okay. And for checking the values of sin x by 2 and cos x by 2, which of these is greater, we'll have to draw the graph of sine and we'll have to draw the graph of cos. Let's say we draw up till pi by 2, although we don't require the graph up till pi by 2. We require the graph up till pi by 8 only. This here is pi by 4, this here is pi by 8. This point is pi by 8. This is 0. And which of these values is greater? This is cos and this is sine. As you can observe, cos is greater. Okay, but both of these are positive. Since this is positive, this is positive, this is overall positive. This is positive, but this is greater, so overall value is negative. Okay, this overall value being negative, this will open with a minus sign. Okay, that's the important step. This further gives me cot inverse of, this opens as sin x by 2 plus cos x by 2 minus sin x by 2 and minus or minus plus cos x by 2 over here. What about the denominator? The denominator will be similar terms. This will again be negative, minus and minus becomes plus, and this will become plus sin x by 2 minus cos x by 2. Can you observe that some terms will cancel from the numerator, from the denominator? And once you have observed this much, this will further convert into what? This will further convert into cot inverse of cos x by 2, which is 2 cos x by 2, 2 sin x by 2 in the denominator. This becomes cot inverse of cot x by 2. Which is equal to, since x by 2 lies in the interval 0 comma pi by 8 first quadrant, therefore cot inverse of cot x by 2 is simply x by 2. And is this the RHS? Yes, that is the RHS. That's the complete proof of this question over here. That's the complete proof of this question over here. Is that all? Yes, that's all for the question, as you can see. Let's discuss this question next. What does the question say? 11th, tan inverse of root plus 1 plus x minus root of 1 minus x over similar expressions in the denominator, that is root of 1 plus x plus root of 1 minus x is equal to pi by 2 minus half cos inverse x, where minus 1 by root 2 is less than or equal to x is less than or equal to 1. There's some interval of x also given, and this one special thing which is given over there which will help you solve this question. But had this thing not been given, what thoughts would have occurred to our mind? You observe this cos inverse x with a half. Yes, if this is some angle theta, right? Well, imagine this is some angle theta. So 2 theta will be equal to cos inverse x, and x will be equal to cos 2 theta. That's the idea that we'll get from here about the substitution of x for simplifying this, right? You can imagine half of cos inverse x, if this is equal to theta, cos inverse x will be 2 theta, therefore x will be cos 2 theta, and that's the substitution that we want to use. Now the benefit of that substitution, let's see. This is 1 plus cos 2 theta, right? What does 1 plus cos 2 theta simplify into? This is something which we have studied in trigonometry, and let's see what does 1 plus cos 2 theta simplify into. This is 2 cos square theta. What about 1 minus cos 2 theta? This also simplifies into 2 sin square theta. Okay. So I observe that this will be cos theta minus sin theta, cos theta plus sin theta. There will be root 2 or something, but those will get cancelled. So cos theta plus sin theta, cos theta minus sin theta over cos theta plus sin theta. This is something which is again borrowed from trigonometry, concepts from trigonometry. I can divide by cos theta sin theta, I can write it as 1 minus tan theta. Dividing by cos theta, this can be done as this. And this further can be observed as tan pi by 4 minus tan theta, 1 plus tan pi by 4 times tan theta. Tan pi by 4 is 1, right? So this is tan pi by 4 minus tan theta, 1 plus tan pi by 4 tan theta, which is tan of pi by 4 minus theta. I'll write all of these steps over here again, but then these are the ideas that we are borrowing from trigonometry for solving this question of ITF. right? Let's see this question. Let x equals cos 2 theta. If we begin with this, the LHS can be simplified into what? Tan inverse of, you have a huge expression over here. What is that? Root of 1 plus x, which will be written as root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta over similar terms in the denominator separated by a plus sign now. This is what you'll have, right? This is further equal to tan inverse of, what is this? This is 2 cos square theta. And can you guess the values of theta from here? From here. Let's also calculate the values of theta, guess the values of theta from here. We have cos inverse x by 2 equals theta, or cos inverse x equals theta. If x lies in this interval, minus 1 by root 2 to 1, you remember the graph of cos inverse? Yes, this is the graph of cos inverse. It is a decreasing graph. Okay. So the lowest value will be cos inverse 1, which is 0, is less than equal to 2 theta, is less than equal to, we are talking about cos inverse x, right? 0 is less than equal to 2 theta, which is less than equal to cos inverse of minus 1 by root 2. Now minus 1 by root 2 is somewhere here. So this is minus 1 by root 2. The output is pi by 2 and pi, the middle of pi by 2 and pi, that is 3 pi by 4, right? Okay. From here I can guess the values of theta. This is range of theta values. This is 3 pi by 8. So theta lies from 0 to 3 pi by 8. Okay. 0 to 3 pi by 8 is actually 3 pi by 8 is less than pi by 2. This is still in the first quadrant. We are still dealing with first quadrant. Okay. So this is root 2 cos square theta, the under root will be equal to modulus of cos theta, which is simply cos theta, right? Since theta lies in the first quadrant. So this is root 2 cos theta minus root 2, same thing. This becomes sin theta. Once again, first quadrant, sin theta will open as positive. Modulus of sin theta will be sin theta. This is again same terms in the denominator. Similar terms in the denominator, but separated by a plus sign this time. Root 2 plus. Now can I divide by root 2 cos theta in the denominator and numerator both? Yes, I can do that. Let's do it. 1 minus tan theta over 1 plus tan theta. This is what I get by dividing numerator and denominator by root 2 cos theta. What next? This will further be equal to tan inverse of, do you observe that 1 is actually tan of pi by 4. Oh, we already saw that over here. Yes, I am writing that exact same thing, something which we already remember. I am expressing that again over here. This is tan theta 1 plus, this is tan pi by 4 times tan theta. Tan pi by 4 being 1, we can multiply by 1 very easily, right? This is equal. This becomes tan of pi by 4 minus theta. Yes or no? Yes. Now what about those values of pi by 4? This value pi by 4 minus theta. Since theta lies in this interval, we know that pi by 4 minus theta will lie in the greatest value will depend upon the least value of this. This is pi by 4. And the least value will depend upon this 3 pi by 8 over here. Pi by 4 minus 3 pi by 8, which is 2 pi by 8 minus 3 pi by 8. This is minus pi by 8. This over here. Is that okay? Yes. Minus pi by 8 to pi by 4. This is pi by 4 minus theta. From this to this value, this is fourth or first quadrant only. In fourth or first quadrant, tan inverse of tan x is simply equal to x. Therefore, this is pi by 4 minus theta. Now what is theta? 2 theta is cos inverse x. Theta will be half of cos inverse x. S inverse x. This. And yes, this is my RHS. That's a complete proof of this question. That's a complete solution for this question over here. Proof? Yes. Is that all? Yes. Let's solve this question next. Prove that 9 pi by 8 minus 9 by 4 sine inverse 1 by 3 is equal to 9 by 4 times something. Do you observe that this factor of 9 by 4, 9 by 4, 9 by 4 is also present over here? Yes. Why is this 9 by 4 so important? There's nothing special about this 9 by 4. Okay. Okay, so can we begin with this complicated version in the LHS? Yes. Let's take out 9 by 4 common. Let's not worry about that 9 by 4 too much. What you get is 9 by 4, this will become pi by 2 minus sine inverse 1 by 3. And now if you observe, this is a very simple question, yes. Pi by 2 minus sine inverse something will be equal to cos inverse something. How is that? Since cos inverse x plus sine inverse x is equal to pi by 2, therefore pi by 2 minus sine inverse x is cos inverse x. This is 9 by 4 times cos inverse 1 by 3. Okay. But we want something else. We want this, no, we want sine inverse 2 root 2 by 3. Then 9 by 4 is already there. We just have to use interconversion of ITF. Okay. So let cos inverse 1 by 3 is equal to theta, which gives me cos theta is equal to 1 by 3. Theta lies in the first quadrant. As you can observe, the value of cos theta is positive, right? This gives me sine theta is equal to under root of 1 minus cos square theta, which is this 1 by 3 whole square. What is this? This is 9 minus 1, 8 by 9 under root, which is 2 root 2 by 3. Sine theta is equal to this. Therefore, theta will be equal to sine inverse 2 root 2 by 3. Okay. Therefore, LHS will be equal to 9 by 4 theta, which is 9 by 4 sine inverse of, we observe sine theta is this, therefore theta will be equal to sine inverse 2 root 2 by 3. Oh, but this is what we wanted, right? This is the RHS, and yes, that's the complete proof of this question. Pretty simple question. Yes, a pretty simple question. Let's talk about this question next. 2 tan inverse cos x. This question is related to solving of equations. Okay, 2 tan inverse cos x is equal to tan inverse 2 cosec x. How do we go about solving this question? Okay, for solving this kind of a question, what we'll do is we'll try to simplify and solve using principal values, and then check the answer at the end. For ITF equations, we check the answer at the end, right? So 2 of tan inverse, 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Let's use this. This gives me tan inverse 2x 1 minus x square is equal to tan inverse 2 over sine x. You can observe this carefully. Yes, this is simple. Okay, we have used using 2 tan inverse x is equal to tan inverse 2x over 1 minus x square. Okay, but for this there was a condition. Yes, x square should be less than 1. Here, although this condition is satisfied, there is no need to worry about this. Since cos square x is less than equal to 1. Yes, equal to 1 is not allowed in this case, right? For what happens in case of equal to 1, you can solve that separately, right? Cos x equal to 1 will imply this is 2 tan inverse 1. This will also be equal to something, and they will be equal. This is tan inverse 1, which is pi by 4. 2 pi by 4 will be pi by 2. And in that case, this will not be defined, I suppose. Yes, this will not be defined. Since this will not be defined, there will be an issue, right? So that particular point does not lie in the domain. No, never mind. So we're solving this question for other points, right? For other points. And in that case, this is where we have reached tan inverse of something is equal to tan inverse of something else. Those two things will be equal next. We can say that 2 cos x will be upon 1 minus cos square x. 1 minus cos square x is actually sine square x, right? Will be equal to 2 over sine x, right? Therefore, this gives me 2 and 2 get cancelled. Sin x and sin x get cancelled. Cot x equal to 1, or which gives me x equals pi by 4. Oh, is that so? Yes, that should be my answer. Check other answer. Cos of pi by 4. This is 1 by root 2. 2 tan inverse 1 by root 2. Cosec of this 2 tan inverse 2 root 2. That's what we'll be getting, right? So 2 times tan inverse 1 by root 2 can be simplified in this manner to get that same thing. Yes, and therefore the result that we obtained is okay. That's my answer for this question. Always check your answer in case of ITF equations. That's the final answer. Yes, that's the final answer for this question. Let's solve this one next. Solve the following equations, tan inverse of this complicated expression. How do we go about solving this one? Now, had this been 2 tan inverse x, we could have simplified it into tan inverse 2x upon 1 minus x square. But we don't have that liberty right now. So what are we supposed to do with this one? With this one? If you observe, there's a possibility of making some kind of substitutions in case of x, or we can solve it directly. Instead of working with this 1 by 2, let's bring this 2 over here. 2 tan inverse 1 minus x over 1 plus x, which will be equal to tan inverse x. Okay, x is greater than 0. Now this 2 tan inverse something can be written as single tan inverse of 2 times that something, 1 minus that something whole square. Yes or no? Yes. This can be written as this, tan inverse 2 something plus 1, upon 1 minus that something square. Now tan inverse of x is equal to tan inverse of y something. Therefore, this quantity is equal to that x. Okay. 2 times 1 minus x over 1 plus x over this. What is this? 1 plus x whole square minus 1 minus x whole square over 1 plus x whole square. This whole quantity is equal to x. This whole quantity is equal to x. That's what we have done, right? What next? Let's bring this denominator and the numerator over here. Yeah. This will further give me 2 times 1 minus x over 1 plus x times 1 plus x whole square whole divided by this quantity. This is in the denominator. This is actually a square minus b square. Yes. Which is a plus b, a minus b. If you add these two together, 1 plus x plus 1 minus x, what you'll get is 2. If you subtract these two, 1 plus x minus 1, minus or minus x becomes 2x. This is 2x. What is that equal to? This is simply equal to x. Right? Yes. What else? This is 2 times 1 minus x. And there is a 1 plus x which remains, because this 1 plus x will get cancelled, right? There is 4x in the denominator which will go in the right hand side. This is 4x square. Okay. Simplify this further. This is 1 minus x square and this is equal to 2x square. Oh. We have just cancelled the factor 2. Therefore, x square, or you can say that 3x square equal to 1. X square is equal to 1 by 3. And since x is greater than 0, x will be equal to 1 by the square root of 3. That's my answer. Have you checked your answer? No. Let's check it. Tan inverse 1 by root 3 is equal to pi by 6 times 1 by 2 is pi by 12 on the RHS. Okay, what about the LHS? You have tan inverse 1 minus 1 by root 3, 1 plus 1 by root 3. This becomes root 3 minus 1, root 3 plus 1. Root 3 minus 1 upon root 3 minus plus 1 is actually tan pi by 12. So this will be pi by 12. This is also pi by 12. Is this answer okay? Yes, this answer is okay. That's the complete solution for this question, as you can see over here. Is that all? Yes. Let's try and solve the next question. Sine of tan inverse x for mod x less than 1 is equal to, which of these options is correct? Now, sine of tan inverse x, can we simplify this? Yes, we can simplify this very easily. This once again using concepts of interconversion. What do you have? For let y equals sine of tan inverse x. Okay. If tan inverse x is assumed to be something and tan inverse x is equal to theta. Let us assume tan inverse x is theta. This gives me x equals tan theta. Okay. Therefore, y equals sine theta. And what is that? That is question mark actually. We are supposed to find sine theta. Okay. We are supposed to find the value of sine theta with the help of this tan theta equals x. Since tan theta is equal to x, can I easily find the value of sec theta? Yes. On the basis of sec theta, I get the value of cos theta. And using tan theta, cos theta, I can get sine theta. Yes. Since tan theta is equal to x, which gives me sec square theta is equal to 1 plus x square, which is 1 plus tan square theta. Okay. From here, I get sec theta is equal to under root of 1 plus x square. Yes. Yes. Okay. And what else? This gives me cos theta is equal to 1 upon under root of 1 plus x square. Therefore, sin theta is equal to what? Sin theta is equal to, sin theta upon cos theta is tan theta. Therefore, sin theta is tan theta times cos theta. What is that? Tan theta is x, cos theta is this. This is what I get. And which of these options is correct? X upon under root of 1 plus x square. Option D is the correct answer for this question, as you may observe. Let's take a look at this question next, 16th. Sine inverse 1 minus x minus 2 sine inverse x is equal to pi by 2. Then x is equal to what? How do we go about solving this one? Since this is a equation based, this is an equation based on IDF, let's try to solve this directly among principal values, right? Okay, this is sine inverse. Can I write it as pi by 2 plus 2 sine inverse x? Yes, maybe. Why did you do that? So that I can take a sine throughout and bring the sine over here. This will give me 1 minus x is equal to sine of pi by 2 plus 2 sine inverse x. Okay, what's the benefit of this? Sine of pi by 2 plus theta, sine of pi by 2 plus theta will be equal to what? Sine of pi by 2 plus theta will be equal to, this is the second quadrant, it will be equal to cos of 2 sine inverse x. Okay, now cos of 2 theta, what is that equal to? Cos of 2 theta is cos square theta minus sine square theta, or it can be done as 1 minus 2 sine square theta. Benefit, this can be done as 1 minus 2 sine square theta, which is sine inverse x. So this is sine square of sine inverse x, or sine of sine inverse x whole square. Whole square. 1 minus 2 sine square theta. What is sine of sine inverse x? That's simply x. Okay, so this gives me 1 minus x is equal to this, or it gives me 1 minus x equal to 1 minus 2x square. Okay, okay. What else? What else? Observe next. This gives me x equals 2x square. Okay. From here, I can note that x equals 0 or x equals 1 by 2. And x is equal to, that's the question that is asked, right? We'll have to check the answers that we have obtained. Let's check 0 first. This sine inverse 1, which is pi by 2, minus 2 sine inverse 0, which is 0. Pi by 2 minus 0 is pi by 2, which implies that 0 is okay. What about this 1 by 2? Let's check this 1 by 2. 1 minus 1 by 2 is 1 by 2. Sine inverse 1 by 2 will be equal to what? Sine inverse 1 by 2 is pi by 6. 2 sine inverse 1 by 2. Oh. Is it 2 sine inverse 1 by 2? Yes, this is 2 sine inverse 1 by 2, which is equal to, once again, this was sine inverse 1 by 2. This is minus pi by 6 actually overall, which is equal to pi by 2. No, this is not equal to pi by 2. Therefore, x equal to half is not correct over here. The correct answer for this question should be only x equal to 0, which is option C. That's the correct answer for this question over here. Let's solve this question next. Tan inverse x upon y minus tan inverse x minus y upon x plus y is equal to what? Okay, that's the question. Let's try to solve this one next. And how do we approach this one? This is tan inverse minus tan inverse. We can simplify that very easily, but I see one more interesting thing happening over here. What's that? Please observe. Let's observe this tan inverse x minus y over x plus y. Okay, what is happening over here is this. Observe carefully. I want to convert in terms of x upon y. So let's think in terms of x upon y. This can be done as minus of tan inverse y minus x over y plus x. What have we done? I've taken a minus out from here. Tan inverse minus x is equal to tan inverse, minus of tan inverse x. What's the use of this? I'm trying to imagine, converted this in the form tan inverse of 1 minus something, that is x over 1 plus x. Where if x is tan theta, this can be converted as tan inverse 1 minus tan inverse x. Right? Imagine this as this. Tan inverse 1 minus tan inverse x is 1 minus x upon 1 plus x, and this is what you get. Right, I want to use this one. Let's see. Let's divide by y in the numerator and denominator. This is 1 minus x by y over 1 plus x by y. Yes, yes. Once you are aware of this much, then can you write it as this is minus of tan inverse 1. Okay. Minus of tan inverse 1 minus tan inverse x by y. Yes or no? This is tan inverse 1 minus tan inverse x by y. Tan inverse 1 minus tan inverse x by y will be equal to tan inverse 1 minus x by y upon 1 plus x by y. Yes, this is what you get. Okay. So therefore the expression that we were looking at, let's see that expression. Therefore tan inverse x by y minus tan inverse x minus y over x plus y is equal to what? This is equal to tan inverse x by y. The first term remains as it is. Yes. The second term is this. This is equal to minus of this plus this. There's already a minus over there. Minus of this becomes plus. Tan inverse 1 minus tan inverse x by y. And if you observe carefully, this plus this minus this term will get cancelled. What you'll get is tan inverse 1, which is equal to pi by 4. That should be the answer. Yes, that should be the answer. The correct answer is option C, as you can clearly see over here. But so this is pretty complicated. If you can observe this, then very well. But if you can't observe this, at least you can apply that kind of a result over here directly. Tan inverse x minus tan inverse y, right? Tan inverse alpha minus tan inverse beta, in that manner. And if I apply that result directly, I'll have some more calculations, but I'll still get the same answer. Tan inverse 1, that is pi by 4. You can use that approach as well. This is a simpler approach, relatively simpler, but some more application of brain is required in this question over here. Okay. Is that all? Yes, that's all in this question. Not only this question, that's the end of this miscellaneous exercise as well as the chapter of inverse trigonometric functions, chapter 2 of mathematics. We have completed the chapter. Yes, we have discussed all the questions. And if you have enjoyed watching this video with us, please like and share this video. Dear friends, also subscribe to our channel of Vyas Edification for latest updates related to all competitive exams as well as NCERT discussions that are ongoing right now. Till the next video, all the best.